Today I'll be solving LeetCode number 1011, ship packages within D days. It is a medium question on LeetCode and it is very closely related to Coco eating bananas, which I've already covered on this channel. Now if you've done Coco eating bananas, the question itself, you already know kind of like the trick to it. So you know that in Coco eating bananas you had to pick a higher bound for your rate and your lower bound for your rate, and you can apply the same exact logic to this question as well. You just have to figure out how to apply the how to get the maximum days and the lowest days. But if you have not approached Coco eating bananas, I would definitely consider doing Coco eating bananas before this question, simply because it makes this question a lot easier. But if you haven't, then the thing with binary search, right? What we want to establish in this question, binary search is the main pattern for this question, by the way. I've already covered it in depth, but the main thing about the binary search in this question is you have to establish a low, as in a low weight, and you have to establish a high weight such that you can perform like a binary search from low to high, trying to get your minimum rate. So that is the same exact thing with Coco eating bananas. That's why I would suggest doing Coco eating bananas, because getting the low and high in that one is a little bit more straightforward than this one. That being said, I'll now show the way to approach this question. So our left bound, actually, the lowest weight that we can go with this question, it's actually so in Coco eating bananas we picked one as our eating rate. In this one we will actually pick the maximum. Now why the maximum? Well, it's because if you have a ship and you had to ship out the rate, so you have to break it into an array, right? You had like 2 2 4 4 1 2, right? The best way to break it up would be to consider the maximum of the array, and by that you would gather or cluster all of the lower valued weights into one part of the array, and you could safely establish the fact that if you have your left being the max weights, then you have some day, like you have some day, such that even if you went one by one, you would still be able to complete it in some X days. But what is the best possible weight that we could pick, right? What is the highest possible weight actually? If we picked right as our sum actually, so if we pick the sum, why the sum? Okay, so in Coco eating bananas, it was you had to finish your pile, right? You had to make it 0 essentially before you moved on to the next one within that hour. How do you ship all containers within the same day? Well, if you have the sum as your maximum capacity, then you can just ship all the packages, right? So if we had, let's say, an array of 1 2 3 4 5, then considering the sum of this, so 5 6 by 2 3 15, considering 15 as the weight would be the best approach, because you can ship all the containers. You can just take this one array 1 2 3 4 5 and ship it off, and your D would just be equals to 1. So that is the best rate that you could possibly have, but we're trying to minimize it, right? So now the part of this question, which is extremely similar to Coco's eating bananas, is just setting up a binary search while left is less than equal to right. I'll erase this part now. While left is less than equal to right, we get our middle. Now we have to define a function, right, to be able to assess whether this specific rate that we are going for can actually ship it within the D days. So how do we figure out the arrays that we can take, the sub arrays that we can take to maximize our potential, to minimize our days taken actually? So we can define another function, can carry, right? And this will take some x integer, that is our middle over here. Now how do we determine that? We always start off with day equals to 1, right? Because you would need at minimum 1 day to ship all the packages. Now to consider the splitting of the array, we don't need to give out the sub arrays, right? So don't be bothered about storing the sub arrays. Just be bothered about when the array would go out of bounds. So how would it go out of bounds? When you have 4 weight and weights, when would it go out of bounds? Well, it would be when the current that you had, like the currents of your subarray plus this new weight, would exceed our capacity, right? X our capacity, bring it back here, X our capacity. Then we would need a full new day. We would set our current equals to 0, because now we would consider a new day, and current plus equals to our weight, right? Otherwise, now at the end just return, at the end I would prefer returning a boolean value, simply because it makes this binary search part a bit easier. So day is less than or equals to days. The amount of days it took for you is less than or equal to the amount that they have given to us. Now I've stored that as a result. So if not result, right, when will it not be result? When the opposite is true, right? So that means we need to increase our rate. How do we do that in binary search? Well, we just increase our left. If not though, that means we have satisfied the requirements, and now that we have satisfied our requirements, we want to minimize it, right? So we will look from 0 to middle, left to middle essentially. So we would move our right, but before we do that, we would also store our middle, right? And then we would do middle minus 1. Why would we store our middle again? This is the same thing that we did in Cocos Eating Bananas, but to explain it again, res equals to middle, because you would store your result would be the minimum. You can never retain middle in this question, because you might have a value that's lower than that. That's why you would want to set it to some value, and then you would actually just do this, because at the end of the while loop, your res equals to middle will always store the minimum. And that's it for this question pretty much. Just store your res as right in the worst case. Here's, store it over here.